Good evening, everyone. Today we like to talk about Zksync, the first ZK knowledge roll-up technology. So the idea is how we can deposit token from L1 to L2. It looks like this is a bridge. So basically, you're going to log tokens on L1, like Ethereum, and then we are going to send all token over to L2, and in L2 you're going to mint some tokens. Okay, and on the other hand, if you want to withdraw, we are going to burn the tokens on L2 and then mint the tokens on L1. So this is two different transactions. Today we are going to focus on the first one. In other words, how we can deposit token on L1 so that you can mint the token on L2 in one as atomic operation. Basically, you want to make sure that people cannot just mint the token on L2 without burning first. Okay, we are only going to focus on L1 today. It's already very complicated. So if you look at diagram on L1, we have a bunch of contracts work together to achieve this. And the entry point is this contract called L1 ERC20 bridge. You call a deposit function over here, then L1 ERC bridge is going to work closely with L1 asset loader, as well as L1 nullifier, L1 native token vaulter, and bridge hub, and all the way to the Zksync to do all the preparation. You can speak it this way, so that eventually we are going to emit an event over here, so that the event can be captured by the layer and then continue the transaction on L2. Okay, so this is why over here, because L1 and L2 cannot talk to each other directly. We have to go through the relayer. The relayer is going to listen to the event on L1. After they capture the event they are interested, subscribe to, and then using the event data, trying to call a transaction on L2. So basically, L1, this relayer have at least have two wallet to address. It can call L1, and it can also call L2. So this relayer have two wallet on both blockchains here. Okay. So let's look at how we can achieve this. Basically, there are three steps. First of all, when you call the deposit, you are going to transfer your token. Let's say we have a DAI token. We're going to transfer DAI token to the LE ERC20 bridge. So that's the first step. Second step is L1 asset loader is going to transfer the token from the LE ERC20 bridge, which usually we call legacy bridge now, because this is the old interface. So from the legacy LE ERC20 bridge, and then move that token eventually to the L1 native token vault. It's a vault. You can consider vault is like a bank. So eventually it's going to move to the bank. Okay. So that's the second step. And the third step is it's going to send the create a transaction for L2, and that transaction L2, the detail will be filled here. Choose this Zksync, which is ERA chain. But Zksync might have now many chains nowadays, but today we are going to focus on one of the chain, which is the most famous one called ERA chain. So let's say this ERA chain, and then we are going to emit an event over here. Okay. So just remember, send a token to the legacy, transfer to the L1 native token vault, and then create a transaction and emit an event at the Zksync. Okay. Turns out it's actually pretty complicated. You might be wondering why it's so complicated. In the beginning, I thought I understand everything already. I thought it's very simple until I draw everything down. I look at this one, wow, it's so complicated. And then before I give this presentation, I digested, and now it becomes a little bit more clear and more simple. So basically, when you look at these, I want to map a little bit to you. These three over here is trying to figure out if the token you are going to send is registered or not. If it's not registered, it's going to register with the bank, which is native token vault. The second part is the second branch over here. So this is the first branch. The second branch is basically transfer the token to the vault. You know, how complicated can it be? Just transfer to the vault. Why is it so complicated? We will explain. Okay, we will explain. But the reason it's complicated is because you have to prepare the information so that those information can be picked up on L2 as well, not just transfer the token to the vault. You have to also prepare the mint data. Remember over here, after we log the token, actually we either can burn or log the token, or we can and then those burned and the logged information need to be captured so that you can use those captured information to mint the token here. So capturing those information, what we call the mint data, is important. That's why it's not trivial to just send the ERC token from the legacy bridge to the vault. So once we have done this branch, then we are going to go the third branch over here, which is going to prepare the transaction file too. And over here, we have two branches, as you can see. The first branch is we need to also collect the gas at this point, not just ERC20 token that you want to send over. So this is why we go back over here all over again to basically log the gas. Okay. So this is why this is run again. So the first time you run this branch, the second branch is to transfer the ERC20. The second branch is to transfer the gas fee. Okay. And then we are going to follow this branch. So in this presentation, please pay more attention to this red path because this is the real deal. The rest of that is just, I would say, bookkeeping and preparation and transfer the token. That's it. But this, along all these paths, is trying to prepare the transaction and then all the detail, and then emit. The last step is new priority request. So this is put the event on the blockchain so the relay can pick up the event and try to call transaction on L2. All right, so I'm going to dive into the code now. Hopefully, we are going to have correspondence between let me see, where is the transaction? All right, here we go. So the first one we are going to look at is, I have to move this all the way here. So the first one we are going to look at is L1 ERC20 bridge. We're going to call the deposit right here. Okay, we have a few arguments to fill out. Who is going to be the receiver on the L2? What token we are transferring and how much? We also need to specify the gas limit, which is the gas we want to spend on L2, as well as the price of publishing the data on L2 over here. So it's called L2 transaction gas per pub data. Each byte, how much you need to spend. Okay, so this is the so this one we have to in the counter test we have to set this one is 200 or 800. I'm sorry. So this is by configuration. Okay, by configuration of the blockchain, one of the configuration matter. You call another deposit. Basically, You just specify if the deposit fail, or if you pay more gas than you need, then who should be the refund the recipient. So you specify the some name over here. If you specify address 0, that means you will be the refund the recipient yourself. So that's a wrapper for this. So this one have two steps. The first one is approve funds asset loader. So this one basically is simply transfer the simply transfer the ERC20 token, let's say DAI, from the user to the to this contract, which is the legacy bridge. Okay, and then you also give allowance to the L1 as a loader. So in this way, later, the L1 as a loader, can move the fund from the bridge to directly to the token vault. Okay, so that's the what we are doing here. And then the next step is, as you can see, is we are going to call L1 asset loader, the deposit ERC20 bridge. So it's right over here. It's right over here. And then this one is a little bit more complicated. First of all, it's going to ensure the token is registered. Each token address is actually translated into the so-called SID, which is a bytes 32. Okay, so if not, it's going to be registered first. So this one will ensure it's going to be registered with SID. And we also do registration if necessary. And then it's going to approve the native token, the allowance. So the native token can also move this token as well. Okay. Let me see. So, and then we are going to burn. This is a very important step. And when you burn, it's going to prepare the main data for L2. Okay, you burn this, but you're going to main on the L2. So we have to prepare the data here by this function as well. And if you look at the burn over here, the next step of burn is going to call the function of bridge burn. So this burn is actually to nothing but a wrapper for the bridge burn in native token vault. Okay, so in other words, the burning is not happening in L1 as the loader. The real burning is happening on the vault. So let's go there. So I think one of the complexity, as you can see, is the separation of concern. It's almost like the American democracy. Why is it so complicated? Security, right? You don't want one. It's powerful if one branch do all the work. So it's almost using some idea over here. It's not just 3 branch now. It's so many branch. So each one is doing its own thing over here. Let me go back over here. So it's going to be bridge burn, I believe. Yes, bridge burn. Let's go to bridge burn. Oh, maybe it's in its parent. Okay, it's in its parent. So I should also give a comment over here. It's in the parent category. Okay, so it's in the vault, but it's in the native token vault. It's a parent of the L1 native vault. So it happened to be it's the same contract, but it's in the parent. So over here, as you can see, it's going to be or there might be two cases, either breach the token or breach burn native token. So what's the difference these two? This is a classic token, like we now like Ethereum or ERC20 token, but Zksync also have a special kind of token called a breach the token. In other words, these are the tokens not created by I think you and me, like the user. These are tokens created by 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 Zksync automatically for us. So I think the idea is in the future, if you create a token on the L2, uh, the Zksync can automatically help you to create token on L1, and vice versa. You have a token on L1, Zksync can also automatically create a token on L2 for you, and that token is called bridge token. Okay. Today we are not going to talk about bridge token, but I think the idea is, you are going to burn the token here, and then mint the token on L2. Today we are going to only focus on bridge burn native token, so which is in our diagram, it's going to be the second branch. The first branch is for the bridge burn native token, or the bridge token, and the second one is bridge burn native token. So the word native in this example is not only including the Ethereum native token, but also including ERC20 as well. So if you look at these bridge native token, we have two parts. First of all, is we are going to transfer the fund. In this case, it's going to transfer from the bridge uh, to the native token to the vault, native token vault. But I put a question mark over here because it might succeed, it might not. Okay. And then the second branch is again doing the transfer also. And in addition, it's going to create the main data. The last step is always create the bridge main data. And in the case that the first branch didn't transfer the money successful, over here we are going to transfer from the original sender. Okay, so this one and this one, only one of them need to be successful. We don't need to do both of them. So there's a check to do that. And then this one is going to increase the balance for that particular token on L2. So we can keep track of how many balance is transferred from L1 to L2. Okay, so let's dive into it. So there are some housekeeping which is down here. So let's follow the bridge burn native token. Let's look at this one. Oh, I'm in trouble right now. It might be in its parent. So parent. Bridge burn, or maybe it's in its child. In its child. So it's a little bit awkward now. I'm going to close this and do it again. Native token value. Okay, let me see if this is good enough. So we are looking for just something funny happening. we are looking for a bridge burn and then bridge burn token. We are looking for bridge burn native token. Okay, let me check that. Okay, so here we go. So we have bridge burn native token over here. This is the second branch. And over here, as you can see, we transfer the token from the L. This is a L1 as a loader. Okay, and then we have a Boolean variable over here to check if the transfer is successful. Okay, I'm not going to look into this function closely. You can take a look at this. So this basically is going to transfer the token from we can take a look. Actually, we can take a look at this because it's important to see how it's transferred. So we are going to look at as a loader. Okay, so this is going to transfer from L1 bridge. Okay, so there are two cases. The first case is the legacy bridge already give this contract enough allowance. So that means the legacy bridge already have the fund. So in this case, we are going to change the original color to be the legacy bridge, and then we specify we can transfer. Otherwise, the second case is the original color. In this case, is Bob. I believe we use Bob as an example. In this case, Bob give sufficient allowance to the loader because sometimes you might use a loader directory without using the ERC20 bridge. And then in this case, we can transfer as well. But in both cases, if we can transfer is true, then we are going to transfer from the original caller, either from the LERC20 or from the original caller Bob to the vault. And then we return true, otherwise return false. So that means we didn't do the transfer. So that's how the transfer funds to NTV work. And then otherwise, we are going to call the parent to prepare the bridge metadata. So let's see the parent over here. The same contract, of course. So the name of the parent is going to be here. I call super bridge burn native token. So in other words, this bridge burn native token is accomplished by the child as well as the parent together. Okay, and parent bridge native token version is essentially checking if it's sending the base token ID. In this case, it's just the Ethereum, but we are transferring DAI, so it should be follow the second branch. So in this case, we're going to make sure that you're not going to send Ethereum right now. So this, if it's not equal, then we have some issue over here. And then this is going to handle the DAI's balance increased by, go back to the child again. This is why it's a little bit complicated. So if it's native, or if the original chain ID is equal to chain ID, then we are going to increase the SID for this particular chain by this amount. Okay. In this case, why is native also increased? Because native is considered gas, but the default gas for every chain. for every chain as well. Okay. So this first case is used to take care of the case of gas, in my understanding. Right. So once we increase this is a handle chain balance, then we will call the deposit funds. Okay. So this is bridge per native token. We're going to call the handle chain balance increase. We already increased it for the DAI token, and for the chain ID in this case, I think it's 9, because we are going to store everything on chain 9. Okay, the chain ID is going to be 9. And then if it's not deposit yet, means sorry about jumping around, means this try is not successful. Okay, so why it's not successful? Because it could be our they didn't give an allowance to the router. They didn't give an allowance to that bridge. So maybe give an allowance directly to the vault. So in this case, the vault is going to transfer the fund itself. So let's look at how this is done. So this vault is going to transfer, they check the balance before and then simply do the token transfer. So the vault do the transfer himself. Okay. So that's basically this is performed by the vault. So as you can see, there's a possibility that the vault transfer the fund by himself. And then it's just checking amount not equal to 0, they don't deposit 0. And then now the final step is prepare the bridge meter data. So L2 can use this data to make any. Not only so, they also emit event over here as well. So in this way, the relayer can monitor this and indeed see, or maybe even check that this amount of token, with this SLID and this chain ID has been burned, and it has been sent by this original caller, and then who is the receiver. So this is very clear, a very important event over here. Okay, so I think that finished the all the way here, second branch. So the next branch is we are going to do the request L2 transaction direct. So that means we are going to go back check to here, deposit Lexi. So we already done the burn part. Okay, the token has been transferred to the right place. Now we are going to prepare the transaction for L2. So this is put the meter data over here into and into the L2 transaction call data, and then that's over here. And then in addition, you have other value, including the gas fee over here. Okay, this is a gas fee we received from L1 ERC20 when you call this. So we're going to do the second step. It's called L2 transaction request direct. This is the most important step in this deposit. So let me see where. I'm sorry. This is just prepare the whole data structure. So this whole data structure is becoming a request. So you create a request and then put that as argument for the bridge hub request L2 transaction direct. So now we are reaching the top component. We are reaching here. I put it in red. It is very important. We are going hit this and then hit the Zksync. So bridge hub is going to create, which also corresponding to here, is going to create the let's look at the bridge hub. So bridge hub L2 request L2 transaction data. You create request already. We create request already, and then there's a few check over here to make sure the value is correct. So they are doing a check to make sure the request mean value is exactly what we received over here. Do a double check over here, and then you also make sure gas fee is not 0. Okay, if it's not matching, then we are going to so this is just trying to make sure if the token SID is Ether, then we need to be the same. Otherwise, you cannot have these 0 over here. And then we are going to so we are going to call this. So in this case, we are not sending the Ethereum. We're sending DAI. So we do have some gas fee over here. We do have the gas fee over here. So this step, essentially, in my understanding, is going to call bridge deposit based token again. But this time, let me see. This time we are following this branch. Okay, for this branch, the token SID is going to be over here, and then we are going to call this bridge deposit based token again, and not going to repeat it. So let me just show you. So over here, go back again and all the way here, but this time it's going to process Ethereum. Okay, but the next step is going to do a call send request, and that's the step I want to follow this time. So so after that, we send the request, and then we fill out all the argument, the chain ID, the refund, the recipient, and then we create a bridge hub L2 transaction request. This is a different format of request, which is created by the bridge hub L2. So so let's go to send request over here. It's a little bit a lot of formatting over here. Yeah, formatting is also another issue. So you're going to do a translation, what the address is going to look like for the refund recipient. And then we look up the Zksync chain map, which is like a registry, to find out what is the Zksync chain address on L1 for this particular chain. Remember, Zksync now supported multiple chains. So this is the chain. In today's example, is ERA chain. We use 9 in this simulation. And then we are going to call the chain. In particular, we call bridge request L2 transaction. So that is actually corresponding to the mailbox.so. It's interesting because actually the ZK chain is using a diamond proxy. So you know, diamond proxy, basically you have a bunch of a contract, but they can all consider as one contract because each contract deployment is like a facet, but you're actually using a proxy. So so that you only have one context. All of these contract is going to run on the same context, which is the context of the proxy, that diamond proxy. So so in this example, we only look at this facet called mailbox facet. And over here, the most important function is bridge hub request L2 transaction. So this name reflect that this is only called a bridge hub request. It's actually a wrapper also, which is wrapper the internal function And then over here, we simply add the authorization. So, but actually, it's a wrapper for the internal function with a similar name. Over here, first of all, it's going to check if these are transactions allowed. So this is access control. Otherwise, it's going to check some parameter, make sure the parameter you provide gas byte limit is equal to the configuration. In this case, 800. And then we're going to prepare a special parameter called price. This price is the parameter we're going to put on the event. And inside prime, the most important field is called request, which is assigned by the request that we take from the bridge hub. And then now we're going to call another internal function, but this one is going to take care of the frames. Here we do a little bit more checking over here and then assign a transaction ID. Okay. And then also deal with the gas fee to make sure the gas fee is sufficient. Calculate gas fee. And then a few other check, make sure the sender is not TX origin. And then it's going to do the most, and then it's going to calculate the expiration time of the transaction and so on. So these are all the details for the planes. And then once you fill out all the planes, you're going to validate it. Basically, to make sure the all the fields are correct, including the gas fee. And the validation also is going to calculate the canonical hash, which is going to be used on L2. You can consider this is unique identifier on L2 transaction for corresponding to this transaction. And then once that is done, this is the most important internal function now is going to write priority OP. Okay, so what write priority OP is going to do is going to first of all write this priority hash into a priority queue. Basically, two information. The first information is what is the hash number and the transaction hash. The second one is the expiration timestamp. So this will be all put into the priority tree. Okay. The next step, the last step is we simply new this event with all the detailed transaction, including non-transaction hash, expiration time, the transaction series, transaction data, as well as factory dependencies. And then the relayer can pick up this event and call L2 transaction. So that's very much how the deposit work only on the L1 side. You have more to do on the L2 side. And also we're going to talk about what about if this deposit fail for some reason. Either fail, it might fail on L2. It's already succeeding L1. That doesn't mean it's going to succeed on L2. Okay, if it fails in L1, there's nothing we need to do because everything will be about it. But the thing is, what about if it succeeds on L1 and then L2 fail for some reason? Then we should be able to take the money back from the vault. Remember, we already either burned or locked the token, the DAI token on the vault. We have to, which is so the money is right here right now. Okay, so we have to take it back if it fails. We will talk about that next time, how to deal with the failed deposit. So thank you so much. Have a nice day.